Well, guys, here we are back, and we're going to talk about the chemical and the physical changes.
Howdy.
Chemical, physical changes. So there's two kinds of changes, Mr. Sands.
There are.
Chemical and
physical.
Physical.
Yeah.
Really?
Yeah, I need to undergo a few physical changes.
Do you?
I'm, kind of getting out of shape.
Getting out of shape. I ran almost 6 miles this morning.
Wow, I chased my kids around the house because they woke up at 5:30 this morning.
Yeah. Well, I was out the door about 6 running. So.
Wow, that's kind of late for you, isn't it?
It was a late morning.
Yeah.
I slept in. Yeah, because I was watching the Giro d'Italia last night.
Yeah.
You
stayed up till what, 9:30? Which is about an hour and a half past your bedtime?
9, actually.
9?
It ended at 9, and I actually fell asleep at about 8:30. So, all right. Physical changes. Okay, Mr. Sampson needs to undergo a physical change, but I think we're talking about a different kind of physical change.
Okay.
Hey, you know one thing we haven't really said in these podcasts, guys? I want to make sure you know that you still need to be taking notes. So you need to be writing these things down.
Make sure you take notes.
So I've got some text on the screen. Substances change from form, but write that down.
Yeah.
And because first of all, that's how we're going to check that you've done the work.
Yep.
And so write it down. All right, pause. Everybody pause. And then write it down, okay? All right. All right, in a physical change, what goes on? Substance changes form.
Yes.
But
do not.
Actually, but do not change formula. All right.
Yeah.
The example essentially of this is if I take water and I take solid water.
Solid water.
Now, what's that better known as?
Ice.
Ice,
baby.
And we use a little arrow, will be a little chemical here, symbol, and it can turn very easily into water.
Liquid water.
Liquid. Okay?
Yeah.
And that's better known as
water.
Okay? And that is called a physical change.
Yeah.
H2O
It's still H2O.
is still H2O.
Yeah.
So, hey, we're good.
So the formula hasn't changed, but it's changed from a solid form to a liquid form.
So these are, usually we think of physical changes as changes of state.
States of matter, like solid, liquid, gas.
Yeah, actually, think of 4 states. Solid, liquid, gas, and although it's not technically a state, it's sort of a form. It's called aqueous.
Oh.
Oh, no, not Texas. Aqueous.
Aqueous, oh, okay.
Aqueous is a special form that's when something is dissolved, and aqueous means water.
Like aqua?
Like aqua, aquatics. I was an aquatic guy when I was a swimmer. Yeah. So aquatic, aqueous. All right, so, yeah. When something is dissolved.
All right.
Now here we have kind of a cool picture here, as deal. What's going on with this particular?
Looks like a little time lapse of some solid water becoming liquid water, just like we saw.
So H2O, that's right.
Solid
so water solid.
Yep.
Turns into water liquid. All right. Good. All right. Now, actually, what we're going to do now is we have a short little video clip showing us talking about this very same thing.
Okay.
In this beaker we have water and ice. It's representing another physical change, solid to liquid. It is still, the chemical is still H2O. It's just going from H2O solid to H2O liquid. It stays at a constant temperature of 0 degrees Celsius. So even though it's still water and ice, it's still at the same temperature. And
so it's a great indicator of a physical change. That's pretty cool, Mr. Sams.
Yeah, it was.
Yeah. Now, this is a picture here of something you've also seen probably.
Yep.
This is water again. It doesn't have to be water. It's just the easiest thing to work with. Water what? I see it
that
kind of
looks
as
like
a...
liquid water.
It's a liquid already,
looks like it's
right?
becoming a gas by boiling.
And it's turning into a gas.
And I kind of question someone's judgment of putting a coffee pot over a gas burner like that.
I know, it's kind of a cool picture.
Maybe it's okay.
When I was looking for cool pictures.
An explosion waiting.
And so if you were to look up here, you would find up here, if you could see them, you can't here, but you could find the steam particles, which of course are water gas.
Yeah.
Which you might just call vapors or steam, whatever, water vapor. But that's little water particles that are now floating in the air after the water boils.
Yep.
Okay. Now let's watch a cool little clip of this as well.
okay, this here we have boiling water. It is a physical change because the chemical composition isn't changing. It's liquid H2O turning to a gas H2O. And if we hold this up behind it, you can see the water vapor behind there. Here in Woodland Park, we're at a higher altitude, so the temperature is actually boiling at 92 degrees Celsius rather than the 100 degrees Celsius as it would be at sea level because of the pressure change in the atmosphere.
Good. And the key thing also, folks, to understand about this water is that it stays at 92 degrees for the entire time. Now, if you are watching this and you happen to live at sea level, Beth Ann, what would you discover the temperature to be?
The temperature would be right at 100 degrees Celsius if it was at sea level.
But us at 8,500 feet, it's 92 degrees. But the key thing to understand is that the water is going from a liquid to a gas, but it's still water. H2O turns into H2O. H2O liquid turns into H2O gas. I found this picture on the internet. I thought it was pretty cool. What a deal is that? Would you like to live there?
That's why I don't live in the Northeast.
Yeah, you think that's Northeast? That seems like a reasonable.
Looks like my car too. It looks like a Ford Expedition.
Yeah, well, it was. I think it's got some issues. I think they're going to file some insurance forms.
Maybe.
And this has already undergone the change that I wanted to refer here. We have water, liquid, which quickly turned into water, solid. And we call that what? What is this process?
Freezing.
This is called freezing.
But this is still a physical change. It's not a chemical change. It's still water.
Yeah, H2O. H2O formula stays the same, doesn't it? Yeah. Okay. And then this one's kind of a cool one. You guys might not know too much about this. Hard to tell in here, but in the bottom of this, there is dry ice. What's dry ice, Mr.
Dry
Simmons?
ice is solid carbon dioxide.
So CO2 solid. And it is turning, now this kind of looks like vapor, steam or something, right?
Yeah.
So what's going on with that?
Well, the dry ice is actually becoming a gas. It's going directly from the solid to the gaseous phase. And in that process is called sublimation. So
sublimation. Sorry about the pen, guys. So, cool, huh? So that's kind of a cool one, too. All right. Now I want to talk about some chemical changes.
All right.
So physical changes, it changes
state
primarily. Solid to liquid, liquid to gas, gas to liquid, gas to solid, or actually go from solid to aqueous, a lot of different changes. Now I want to talk about something that's a little different called a chemical change. Now here, it changes from chemical A to
something new.
To chemical B. All right, like my pen is doing a weird thing, guys. Sorry about that. All right, just making notes here with my pen. All right, okay.
Lovely drawing there.
I know, isn't that kind of cool?
It's kind of like a whale.
It's like a whale, and there's his eye right there.
Ooh, a narwhal with the little nose.
Yeah, don't you see that? So
that's cool.
Yeah,
very nice.
All right, hey, when you see a chemical change, there's 4 things you can tell if you want to see a chemical change. So let's talk about each of those changes. The first one is, you can notice, is this: a gas is given off.
Right. Now this is a gas given off, not to be confused with a liquid becoming a gas. This is when you mix things or modify a chemical some way where it releases a gas, but we're not talking about liquid to gas state of matter change. So a common example of this would be like vinegar being added to baking soda.
So this right here is the chemical for vinegar. So copy this down here, guys. Okay. And then this is baking soda. I'll just call it BS. What do you think? And that makes sodium acetate. My pen. Plus water. Plus
carbon dioxide.
CO2.
Yeah, so let's watch a little video clip and see what happens when we mix these together.
Okay, and notice in the video clip, a gas will be given off, I hope. This is an example of a chemical change. You see, I went to my favorite chemical supply store. That would be the grocery store. And I bought some baking soda and some vinegar. Probably a lot of you have seen this. If I take some vinegar and I pour some vinegar into the Erlenmeyer flask, this is a Erlenmeyer flask, and then I add the baking soda to it, we'll see a chemical change. And I will know it's a chemical change, and I'll tell you why in just a second. Because, as you can see, it's fizzing right here. It's producing a gas, and it's bubbling over, as you can see, and a gas is given off. So one indicator of a chemical change is that a gas is given off. So that was the first one. That's pretty cool.
Very nice.
Yeah, very
Lovely
nice.
mess you made there, too.
Yes, I did. Okay, our next one, we're going to talk about light and heat. So if light and heat is given off, you can see a reaction. A classic reaction of that is that you can take magnesium, and then you can just burn it in the presence of air. And it actually simply just turns into magnesium oxide solid. Yeah. But the key thing is you get tons of energy
and it gets very hot and very bright. Now this actually, if you ever witness this happening, don't stare directly at it, just like you don't want to stare directly at a welding arc, because you will scorch your retinas.
Yeah, that would be that bad. So let's actually watch this very same thing.
Mm-hmm. All right, we're going to perform one more chemical reaction, and we're going to see another chemical change, and let's just do the reaction, and we'll talk about it when it's done. I got my trusty little torch here, and we're just going to light a piece of magnesium, and it's going to react with the oxygen in the air.
That is amazing.
Ooh, so
That
bright.
is so bright, Mr.
So we
Sam.
can see there's light being given off, and I can feel the heat being given off from here as well. So light and heat being given off, those are two indications that a chemical reaction has taken place. And you can also see we had a piece of shiny metal to start with, and now we've got a white powder that's left over. So we also have a color change. This is magnesium oxide. That's what happens when you combine the magnesium with the oxygen in the air. You form a new chemical substance.
Cool. And we had amazing help from our assistant, Beth Ann. All right, this next one is if you see a color change.
Right.
Color changes are pretty cool to see. If you see any kind of a color change, like if you're cooking a steak, does it change color?
Oh man, yeah.
Well,
It goes from a nice red to a nice crusty brown.
there you go. Crusty brown. You must like those like well done.
Oh no! I like them totally rare, but I like the outside nice and
Fair
seared.
enough. I'm okay.
Oh man!
So, anyways, color change.
Yeah.
That is a chemical change.
Couple
Did you know that?
Band-Aids, send it back up to grays.
Yeah.
Oh, that's the kind of meat.
Now, the one we're going to watch here in a little bit, it's pretty cool. You're going to see lead nitrate, so PB. And nitrate is a funny one, NO3. And there's a 2 here. You'll learn more about that later. And we're going to react that with potassium iodide. And that's going to make PbI2. And this is a very cool chemical.
Yep.
Plus potassium
Nitrate.
nitrate. You can put a 2 here, I think, and a 2 there to balance it. We'll learn more about balancing.
Yep.
But this is a very cool chemical, is that when you see this, it's a very bright yellow color. So,
Yeah, let's watch that. Now, in addition to the color change, one more chemical indicator of a chemical reaction that we're also going to see in this is the formation of what's called a precipitate. Now, a precipitate is when you take two solutions, two homogeneous mixtures of ionic compounds dissolved in water, you mix them together, and instead of still having two solutions, a solid forms, and that solid is called a precipitate. Now don't confuse that with precipitation, like rain coming out of the sky, but the solid being formed just kind of means it comes out of and falls down to the bottom. That's really what we talk about when something precipitates. Like rain, it comes out of the sky and falls down to the ground. The solid comes out of the solution and falls to the bottom of the container.
So let's actually watch this cool reaction that we talked about in our previous slide right here.
Yep.
It'll make a yellow precipitate, and it will be solid, as we talked about. And yeah, so let's give our attention to this.
We're going to do another chemical change. This one we're going to mix lead nitrate and potassium iodide. And it's going to form a yellow precipitate, which will also change the color.
Way cool.
It looks like paint.
So why is that an indicator of a chemical change, Beth Ann?
It is an indicator of a chemical change because it changes color and it also forms a precipitate.
Now, what's a precipitate?
Precipitate is any kind of solid, or it looks like the cloudiness of this one also.
So if that's set for a long period of time, what would you see?
You would see a solid or like a powdery substance settled at the bottom of the liquid.
And it would be clear at the top. So it'd be
Clear at the
yellow,
top.
it's like a yellow powder. They actually use this substance, or they used to make paint. So how will you know if a change is either physical or chemical?
Well, if it undergoes one of the four indicators
Yeah,
that
so
we just
for
talked
chemical,
about,
you're
it's
looking for
chemical.
the four indicators. And physical, remember, it doesn't change what it is.
Right.
Okay, so let's just do some examples.
All right.
So what do you got there, Mr. Simmons?
How about I get up in the morning and I crack an egg and I fry it up in a frying pan.
Now, if you cook an egg, when you fry it, it changes a little bit.
It does.
In fact, if I think about it, it changes color, right?
It does change color.
So
it
if
goes
it
from that
changes
clear to
color,
white.
I would call that a chemical change.
Yeah, and kind of brown. So we denature the proteins, and then it starts to react. Those proteins start to bond up with carbohydrates and
Yep.
things like that, turn into new substances.
Actually, I think it changes. Egg whites, isn't it a primary protein, and it turns into a secondary or tertiary protein?
I
or
think
something like
it's
that?
the other way around.
Or the other way around?
actually. Yeah.
Oh, well, something like that.
Yeah.
Anyways, you didn't need to know that. The point is it changes color, and that makes it a physical change.
Yeah.
Or a chemical change. I said that
Yeah,
wrong.
guys, anytime you see the word cooking or baking, it's going to be a chemical change. Okay, those of you who want to go into the culinary arts, it's a good thing you're taking chemistry because it's all chemistry. Cooking and baking is all chemistry.
Here, I got another one for you, Mr. Sims.
All right.
Dissolve salt.
Yeah.
So take salt. We did that a while back in one of our previous video clips.
Well, you know, I put that salt in the water and the salt went away.
It did. It went away.
It did. So let's see. There was no there was no color change.
No change in color.
There was no gas given off.
No gas. I
And
didn't
there
see
was
heat or
no
light.
heat or light. No precipitate. So it probably wasn't a chemical
It's
change.
physical.
It is a physical change. Okay,
It's
by
a-
dissolving it, if I take salt and I dissolve it in water and I drink it, you know what it tastes like?
I think it tastes like
It
salt.
tastes like salt. So there's still salt in there, and it's still salt, and it hasn't become anything else. It's just changed its state.
This is actually how you would write this. NaCl. And the little S, by the way, stands for solid.
Solid.
And the little AQ stands for aqueous.
Aqueous.
And that's with the formula that we would do.
Yep.
What if I were to take some paper
Uh-huh.
and I were to burn it?
Okay. Well, anytime you burn something, you react it with oxygen, and it becomes something else.
Oh, yeah,
And
'cause-
there's a color change.
Color change?
Yeah.
Heat and light?
Heat and light's given
Mhm.
off. Yeah. Good.
So I call that Kim.
Yeah. But no, instead of burning it, I just take a piece of paper and I crumple it up.
Crumple the paper. So
Yeah.
I crumple the paper. Look still, I'm looking at that piece of paper you got in your hand, Mr.
Yeah.
Sims.
And it looks.
Still looks like paper
Yeah.
to me.
Its shape has changed.
Its shape has changed.
And its volume has kind of changed, but
I'm going to call that physical.
I think you're right.
Yeah, and I think you had one more. What was that?
Melting iron.
Oh, yeah, take iron. Just a piece of iron, like a nail.
Mm-hmm.
And you really heat it up.
Really hot.
Really, really hot. You know what happens when you really heat iron up?
You melt it.
It turns into liquid iron.
Yeah.
Liquid iron. All right. What's going on with that?
It's just a physical change. It's still
Yeah.
iron. Yeah, another way to think about this, folks, is, well, I was going to say it's reversible. All reactions are technically reversible, but if you can kind of undo something real easily, it's
Yeah.
probably physical.
Probably physical.
Yeah, it's not the greatest example, but think of if you can undo it, it's probably physical.
Okay. So, folks, that's the end of this quick little podcast. I hope you enjoyed it.
Bye.